Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to explain a class 12th topic. The name of the topic is gold number and the chapter's name is surface chemistry. Students, before starting, I request you to support me by subscribing my channel so that I can make many more useful videos for you. Please like this video and share this video with your friends also. So now come with me and let's crack chemistry. Today's topic is gold number. Students, before starting the topic gold number, there are few important terms which you must know for a better knowledge of gold number. So first of all, we will quickly see what are colloidal solutions. Colloidal solutions are those solutions in which the particle size is in between 1 nanometer to 1000 nanometer. And one more important point I would like to mention here that in case of colloidal solution, we use the term dispersed phase and dispersion medium in place of solute and solvent. So dispersed phase is just like a solute in a normal solution and dispersion medium is just like a solvent. So there are various ways to classify colloidal solutions. One of the important way to classify colloidal solution is on the basis of interaction between dispersed phase and dispersion medium. On the basis of this, there are two types of colloidal solutions. One is lyophilic and another is lyophobic. So now quickly see what are lyophilic colloids. Lyo means solvent and philic means attracting. So lyophilic colloids are those colloids in which dispersed phase and dispersion medium have attraction for each other. So as we have seen that in case of lyophilic colloids, dispersed phase and dispersion medium have attraction for each other. The preparation of lyophilic colloids is very easy. They can be simply prepared by mixing dispersed phase with dispersion medium. And one more important point, if anyhow dispersion medium is removed, they can be prepared again by mixing dispersed phase with the dispersion medium. That's why they are also called as reversible colloids. Lyophilic colloids are stable colloids. They are stable colloids because of the attraction between dispersed phase and dispersion medium. Lyophilic colloids are surrounded by a layer of solvent. On the other hand, lyophobic colloids are those colloids in which there is no attraction between dispersed phase and dispersion medium, rather than dispersed phase repel dispersion medium, because lyo means solvent and phobic means repelling. We can say that dispersed phase and dispersion medium, they repel each other. Contrast to lyophilic salts in which the dispersed phase and dispersion medium have very large attraction for each other. Lyophobic colloids, as there is no attraction between dispersed phase and dispersion medium, they cannot be prepared simply by mixing dispersed phase with dispersion medium. We need some special methods to prepare them, as in the case of lyophobic colloids, there is no attraction between dispersed phase and dispersion medium. So the particles in lyophobic colloids are not surrounded by a layer of solvent. So this is the reason lyophobic colloids are less stable. The colloidal particles, they contain some charge. They may have either positive charge or negative charge. For example, silver chloride salt can be positive charge or it can be negative charge also, depending on the way it is prepared. So in a particular colloidal solution, all the colloidal particles will carry the same charge. For example, if we are talking about positively charged silver chloride salt, all the particles of this positively charged silver chloride salt will have the positive charge only. And if we are talking about negatively charged silver chloride salt, then all the particles will have negative charge only. The presence of charge gives stability to colloidal particles. Why the presence of charge gives stability to colloidal particles? The reason is that in a particular colloidal solution, all the particles will carry the same charge. So there will be repulsion between the similar charged colloidal particles. Because of the repulsion between similar charged colloidal particles, they will keep on moving. and they will not settle down under the influence of gravity. So now, if anyhow, by any method, if we remove the charges on the colloidal particles, what will happen? All the colloidal particles, they will come together and they will form a larger aggregate and they will settle down under the influence of gravity. So children, always remember one point, that charge gives stability to colloidal solution. Charge की वजह से colloidal solutions में stability आती है. तो अगर हम किसी तरह इस चार्ज को रिमूव कर दें, then the colloidal solution will become unstable. चार्ज रिमूव करने से सारे colloidal particles जो हैं वो पास आ जाएंगे and they will settle down under the influence of gravity. And this process of settling down of colloidal particles under the influence of gravity, when an electrolyte is added to it, is called as coagulation. Coagulation of colloidal solutions can be done by various ways. One of the important way is by addition of electrolyte. For other methods, you can refer my videos. From this discussion, it must be clear to you that lyophilic colloids are more stable than lyophobic colloids. The reason is that in case of lyophilic colloids, the dispersed particles are surrounded by a layer of solvent. So this layer of solvent is acting as a protective layer. So on the addition of an electrolyte, this protective layer will protect the dispersed particles. So as you have seen that lyophilic colloids are more stable than lyophobic colloids, we can stabilize lyophilic colloids by adding some lyophilic colloid in it. The lyophilic colloid which is added for protecting a lyophobic colloid is called as a protective colloid. Starch is one of the lyophilic colloid which is used for protecting lyophobic colloids. Now I am coming to my point, that is gold number. Gold number is used to express the protecting power of protective colloids. So what is gold number? Gold number is the minimum amount of protective colloids in milligrams which will prevent the coagulation of 10 ml of red gold salt by addition of 1 ml of 10% NaCl in it. तो हम सीधे से कह सकते हैं कि किसी भी प्रोटेक्टिव कोलॉइड का गोल्ड नंबर उसका वो मिनिमम अमाउंट है मिलीग्राम में. इस मिनिमम अमाउंट को जिसको कि हम मिलीग्राम में एक्सप्रेस कर रहे हैं, अगर हम 10 ml रेड गोल्ड सॉल्ट में डाल देंगे तो ये 10 ml रेड गोल्ड सॉल्ट प्रेसिपिटेट नहीं होगा. कब प्रेसिपिटेट नहीं होगा? जब हम उसमें 1 ml 10% NaCl सॉल्यूशन डालेंगे. तो यही मिनिमम अमाउंट प्रोटेक्टिव कोलॉइड का मिलीग्राम में कहलाता है गोल्ड नंबर. एक पॉइंट हमें और ध्यान रखना है कि लेसर द गोल्ड नंबर ऑफ अ प्रोटेक्टिव कोलॉइड, स्ट्रॉन्गर विल बी द प्रोटेक्टिव कोलॉइड. One more point I would like to mention here, on coagulation of a red gold salt, its color changes from red to blue. In this slide, you can find the definition of gold number which I have just explained you. Now, we will see the numerical. The coagulation of 100 ml of a gold salt is completely prevented by addition of 0.25 gram of starch to it. So, if you add 0.25 gram of starch to 100 ml of gold salt, its coagulation is completely prevented when you add 1 ml of 10% NaCl solution. So they are asking you to calculate the gold number of starch. So what is the gold number? Just now we have seen that the gold number of a protective colloid is its minimum amount in milligram, which will prevent the coagulation of a 10 ml of gold salt on addition of 1 ml of 10% NaCl solution in it. If you look carefully in this question, you can find that the amount of protective colloid is given to you in terms of gram, and the volume of red gold salt is given as 100 ml. But by definition, we need the minimum amount of protective colloid in milligram, which will prevent the coagulation of 10 ml of red gold salt. So we can find out. As the coagulation of 100 ml of gold salt is prevented by 0.25 gram of starch salt. But we have to find out the coagulation of 10 ml of gold salt can be prevented by. So we can calculate here the coagulation of 10 ml of gold salt can be prevented by 0.25 divided by 100 into 10. So if we calculate, our answer will come out to be 0.025 grams. So we have seen that coagulation of a 10 ml of gold salt can be prevented by addition of 0.025 gram of starch in it. But we need this number in terms of milligram. So we can convert this 0.025 gram into milligram. So amount of protective colloid in milligram will be equal to 0.025 into 1000 milligram. So your answer will be 25. The gold number of protective colloid is 25. I hope each and every point is clear to you. Thank you so much for watching this video.